periodic trend in properties. In this video, we are going to study that how atomic radii, ionization energy and electron affinity vary along the period and down the group. That means what is the effect in atomic radii when we move along the period from left to right or right to left, and how does it change when we move from top to bottom in a period and a group. And in same way, we are going to study about the periodic trends in electron affinity and ionization enthalpy also. Let's start. Periodic trends in atomic size or atomic radius. That means we have to study now that how the atomic size varies in a periodic table. Okay. First of all, atomic radii or atomic size decreases along the period. As we move from left to right along a period, what we see that atomic radii decreases. This is why, because nuclear charge increases progressively as we move from left to right. We know, okay, first read this. Nuclear charge increases progressively by 1 unit on moving from left to right across the period. As a result, the electron cloud is pulled closer to the nucleus by the increased effective nuclear charge, which causes decrease in atomic size. Now let's understand this with an example. What we have, let's say we have lithium, then beryllium. We move from lithium to beryllium. In lithium, we know atomic number is 3, and it is 3 for lithium and 4 for beryllium. Okay, now we know that in lithium, and for both of these, n is equal to 2. So we are talking about a particular period, that means n is equal to 2. In this case, this is, let's say, lithium nuclei, and this is beryllium nuclei, the first both with 2 shells. Now what is the situation? That in lithium there are 2 electron in first and 1 in next one. Same situation is here. Actually here there would be 2 in this one and again 2 in this one. So both have almost same number of shells. The first thing, the size depends on number of shells, and in both cases the number of shell is 2. That means both of these must have almost similar size. But the problem is that in lithium there were 2 shells, and those 2 shells were attracted by the 2 protons present in the nucleus. There were 2 protons, actually the atomic number is 3, so there were 3 protons and 3 electrons in lithium atom. These 3 protons were present in the center, in the nucleus of the lithium atom, and these 3 electrons were present in the 2 orbitals. So at this time, the protons which are present in the nucleus are attracting the electrons which are present in the orbitals. As we move to beryllium, again there are 2 orbitals only, or 2 shells only, but there are now 4 protons present in the nucleus. There is addition of an electron and addition of a proton also with increase in atomic number, but the electrons which is added comes into the same shell while the proton goes into the nucleus, and now there are 4 protons in the nucleus which are attracting the same 2 shells, and those will attract more strongly, because of which the size will get reduced. That's why size of beryllium is less as compared to lithium. So similarly when we move progressively from left to right in a period, size keeps on decreasing because the electrons are also increasing and protons are also increasing, but the electrons which are coming into the same shell, while every proton which is added increases the effect of nuclear force, because of which the size decreases. So along the period, size decreases. We can see lithium is of 140, then beryllium is about 110, then boron and carbon and nitrogen, oxygen, fluorine, size is progressively decreasing. while down the group, when we move from up to down in a group, in a particular group, size increases because of increasing number of shells. You can see here. So this diagram represents that along the period size decreases in this area, it decreases when we move from left to right in a periodic along a period, and down the group size increases. This increases because of increase in effective nuclear charge while the number of shells are same, and this increases because of increase in number of shells. In hydrogen there were 1 shell n is equal to 1, in lithium there were 2 shells n is equal to 2, and in sodium there are 3 shells n is equal to 3. So down the group size increases due to increase in number of shells, along the period size decreases because of increase in effective nuclear charge while the number of shells are same. Next is periodic trends in ionization energy. Actually, what is ionization energy? First of all, ionization energy is the amount of energy required to ionize an atom. In definitions, it is the amount of energy required to remove the most loosely bounded electron from an isolated gaseous atom in a ground state. That means, in simplified word, it is the amount of energy which is required to remove the valence shell. One valence electron from the valence shell, it is the amount of energy required to remove an electron from the outermost orbital of a gaseous isolated atom. And let's say this is an atom, this is the nucleus, and electron is present here. Another atom, let's say of larger size, and this electron is present here. Now we know that it is more easy to remove this electron from this atom as compared to this atom. Why? Because here the size is small and the effect of nuclear force is high, because of which this electron is highly bonded to the nucleus and it will require large amount of energy to remove this electron, while in this case the amount of energy required to remove this electron will be slightly less because of larger size and less effect of nuclear force. So this means as the size increases, ionization energy decreases. That's why. Okay, now what are the factors which affect ionization energy? First is it decreases with increase in atomic size, as I just discussed. Next, it increases with increase in nuclear charge. Greater the nuclear charge, more will be the ionization energy. It decreases with increase in number of inner electrons, and also it decreases with increase in number of inner electrons because inner electron repels outer electrons. Actually, if there is electron present inside, it will repel the outer electron, and that's why it will be more easy to remove this electron now. So inner electrons, greater the number of inner electrons, less will be the ionization energy. So it decreases with increase in number of inner electrons, and also but it increases with increase in penetration power of the electrons. We'll leave this one. Next is variation across a period. Okay, we now know that ionization energy depends on, yes, it depends on atomic size highly. Greater the size, less will be the ionization energy. So we know along a period atomic size decreases, and that's why ionization energy increases, while down the group size increases, and that's why ionization energy decreases. So variation across a period, it increases with increase in atomic number across a period. That means when we move from left to right in a period, the ionization energy increases because of decrease in size. Next is variation in a group, it decreases regularly with increase in atomic number within a group. That means when we move from top to bottom in a group, the ionization energy, yes, decreases. That means the first ionization energy of lithium would be greater than that of sodium, while the ionization energy of sodium would be, yes, this is sodium, for sodium it is less as compared to, yes, lithium. Why? Because it decreases down the group. While again, if this is potassium, this would, in this case, yes, it would be more, it would be less. So when we move down the group, it decreases. When we move along the period, it increases. This is how ionization energy varies in a periodic table. It increases along the period, it increases when we move bottom to up in a group, or it decreases when we move from top to bottom in a group. Next is periodic trends in electron affinity. Now, electron affinity is the tendency of an atom to attract the electron toward itself, or it is the amount of energy released when an electron is added to the gaseous isolated atom. It is the enthalpy change or amount of energy released taking place when an isolated gaseous atom accepts an electron from a monovalent gaseous ion. Greater the electron affinity, more will be the amount of energy released. That means more negative will be the electron affinity or electron gain enthalpy. This is also known as electron gain enthalpy. So the atom which has more affinity for the electron will release more amount of energy, and that's why there will be high negative value for electron gain enthalpy. So larger the value of electron gain enthalpy, greater is the tendency of an atom to accept the electron. Greater the magnitude of nuclear charge, larger will be the negative value of electron gain enthalpy. Obviously, the smaller atom will accept the electron easily as compared to a larger atom, because in smaller one the effect of nuclear charge is high. So it will release more amount of energy when it accepts an electron. So for small atoms, the amount of electron gain enthalpy would be larger and negative. Now, larger size of atom, smaller will be the negative value of electron gain enthalpy. Again, more stable electronic configurations of atoms. Actually, if an atom already has stable electronic configuration, it will not accept any more electrons. So the more stable electronic configuration of atoms, more positive will be the value of electron gain enthalpy. Again, positive negative value for being more electron efficient or for showing greater electron affinity, the value of electron gain enthalpy should be negative. Negative means amount of energy is releasing, more negative means more amount of energy is releasing, and more positive means less amount of energy is releasing, that means less electron affinity. So variation along the period, we know as the size decreases, electron affinity increases. That's why along a period it becomes more negative, that means electron affinity increases. While down the group size is increasing, that means electron affinity is decreasing, because greater size less will be the electron affinity. So down the group size is increasing, because of which electron affinity is decreasing, and the sign of electron gain enthalpy is becoming less and less negative down the group. And this is how the electron affinity varies in a periodic table. Along the period it increasing, and when we move down to bottom in a group it again increases, or we can say that down the group it decreases. Down the group it decreases. Now there is solved problem. Moving from right to left in a periodic table, the size is obviously, when we move from left to right in a periodic table, the size is decreased. It's a question, direct question based on a knowledge which was asked in IIT-JEE in 1995. Next is, this is a more latest question. Which of the following represents the correct order of increased first ionization enthalpy? We know that ionization enthalpy highly depends on size, and in a periodic table if you see, argon would have the one which is present in the most extreme right side, so it would have highest ionization enthalpy, and that's what is here. Now we know that among the barium and calcium, this is actually the order of elements in periodic table are like this. This is on the extreme left, followed by calcium comes somewhere here, then we see scandium, then sulfur, and then argon is on this side. So this is the order in which these elements are arranged in a periodic table, and that's why. And we know that along the period, yes, size ionization enthalpy increases because of decrease in size. So the correct order would be like this. It would be C. Students, in case you have any doubt in this topic, you can post that question in our discussion board. For that, all you need to do is to go to the home page of Ask IITians. There you will find an option of discussion board. You have to click there. Then in the right side, you will find a portion of Ask Experts. In that, just select the category in which you want to post your question. Let's say it's physical chemistry. Then post your question here, and then if you want to attach any image, use this option to attach the image, and finally post it by clicking on Get Answer, and you will be answered within 24 to 48 hours by our experts. So students, now we know that atomic radii decreases along the period and increases down the group, while electron affinity and ionization enthalpy increases along the period and decreases down the group. So in next video, we will discuss about some more properties and their periodic trends in periodic table. Thank you.